Well, hello there, Diego. How's it going today?
Hello. I'm doing well. I like the little warning that's like, this call is being recorded. I'm like, oh God. Yeah, I am well.
Diego, I'm so excited. I have some guesses on what topic you're going to be picking today, but I might be surprised. So what did you pick?
I I have two things, and I'm kind of on the fence about them.
Okay.
One of them I think is more interesting, but I don't know how long I can talk about it for.
Okay.
Uh, and the other one I think is what you are thinking, which I can probably talk about forever, but I don't know if I can pick something right. So like the one that I think you're thinking is probably like cars or racing,
Yes.
right?
Yep.
And the other one that I'm thinking of is my experiences with NVIDIA Game Stream and like Moonlight,
Uh,
which I think is much more interesting.
uh-huh.
But I don't know if I can actually talk about that for like an hour, right? Depending on, I don't know how interested you are into knowing what happened and stuff, but like there's some interesting history that went down while I was in college, which I think is fun to talk about. But yeah, so
So what
what
I'm
do you
going to say
think?
to that is I definitely don't have any expectations. Like I said it in the pitch as well. So it could be 30 minutes. It could be 3 hours. It should be the conversation you want to have, if that makes sense. So
Yeah,
I would definitely want to go with the NVIDIA one because we've just talked about it less as friends. Like we've
yeah,
talked about the carb stuff more. And
mhm,
it doesn't matter at all how long we can talk about it. I can
yeah,
ask questions. I can ask lots of questions. So
cool.
what's a good place to start? Like NVIDIA, when many people hear NVIDIA, they just think graphics cards, right? Like what is your
Right.
relationship and how did you get interested in all of this?
Well, I wasn't interested, really. My roommates were interested in college. So what happened was one of my roommates, Cameron, and I'm going to say his name a million times because he's one of the protagonists in this story. But he got he's always been interested in just like weird like gadgets and stuff. Like when smartwatches came out, he got the Pebble. I don't know if you remember that. And I got one as well shortly thereafter, mostly because of them. Um, and he bought something called an NVIDIA Shield when they first came out, which is this, for those people that don't know, it's like this handheld device that's basically an Android phone with a video game controller built in together. So the screen would fold down onto the video game controller to the controller, and then it would like flip open. It's basically an Android device. But what was special about this is that it came paired with this software that NVIDIA called Game Stream, which would allow you to stream games directly from your computer that had a NVIDIA graphics card to this device. And it uses some proprietary NVIDIA software that basically runs directly on the graphics cards and allows extremely low latency streaming. In fact, they say it's faster than real-time streaming.
What does that
And
mean anyway?
what does that mean? It means, so think about like if you were playing a game and you get 60 frames per second, right? Imagine your graphics card can actually render that game at 120 frames per second,
Oh,
right?
okay.
You can
Okay.
actually be doing that. So it'll be rendering those extra frames and sending them. So that's what faster than real time really means. Um, and it could actually do that up to 4K. Yeah,
That's
so this
insane.
technology is actually pretty insane. And it'll do like 4K, 60 frames per second, faster than real time, assuming you have, now I guess they're not that new. At the time, they were the brand new GTX 600 series. So the GTX 650 was the minimum baseline you could have to do this. That one definitely didn't support 4K, but it did support like 1080p, 60 frames per second. So anyways, my roommate Cameron got this device, and we were all like in love with it. We were gamers, and we saw this here like, oh man, I can play all of my games from my desktop while I'm like lazying on the couch, something like that. I can be social while being antisocial all at the same time. Uh, and um, and as I kind of leaked earlier, this device really just runs Android. And so we were like, we know how Android works. Like we can poke around. And we went to a hackathon. This was in Michigan, the MHAX. It's actually one of the biggest hackathons around nowadays. But during this hackathon, we had the idea of trying to essentially reverse engineer how this game stream technology worked, and so we used basically like Wireshark, did a bunch of packet sniffing, and were able to decipher most of the protocol. So we knew that there was an exchange that happens where you pair your device to your computer, and that was sort of how it all starts. Fortunately, at that time, NVIDIA did not use any kind of encryption. This was just done over HTTP, and so we could just packet sniff and just looked at the transactions, and then by just doing like a regular replay attack where we were able to figure out how the pairing worked, and we're able to mimic that. On top of this, we learned where they stored the pairing keys. The way it was stored on the computer was just in a registry. It would store the MAC address of the device that it was paired to. And I'm going to go off on a little tangent here because this is kind of an interesting tidbit that happened this happened after the hackathon, but I'll talk about it now. We noticed that these pairing keys are basically the MAC addresses that were stored in the registry. NVIDIA was doing a prefix check on them, and not a full string check. So it turned out, or rather a substring check, not a full string check. So it turned out that if you had any part of the MAC address in the key, it would authenticate. So for example, if you picked a colon, which exists in all MAC addresses ever, you're automatically authenticated. So this meant for us was that any device that, like anybody who had paired a Shield, an NVIDIA Shield, to their computer, we could also just connect to their computer. And if it wasn't obvious from when I said, basically this gives you full keyboard and mouse access, video, audio, keyboard and mouse. It's basically like remote desktop, but extremely low latency access to their computer.
Wait, let me get this straight. So you were able to use anyone who had paired up their computer with an NVIDIA Shield, you were able to use this back door to get into their computer and get access to everything.
Exactly. Oh, and this also
That's insane.
Runs as it's like part of the driver, so it runs as administrator. So you have administrator access when you do this. But don't worry, it gets better. Also, we did bring this up with NVIDIA, and they have patched it since. We did send them. But this wasn't even the best 0-day we found. It got even better. Is that after they paired, what would happen was the host computer would send back a session ID, and the session ID is what then you would use to make all the requests of like, oh, launch a game, or start the network, the video stream, the audio stream, etc. And without that session ID, it just wouldn't do anything. So turns out they had yet another bug where they were simply checking if they did I forget what the function call is in C, but basically it was like, if this session is greater than 0, compare it to some number, like check if it's the right one, was basically what they were doing. So if you set a session of negative number, any negative number, you're automatically authenticated. And because checking the session ID happened after checking the pairing, like doing the pairing process, having a valid session ID, by definition meant you were paired, which means we could actually start a session on any device running an NVIDIA graphics card, whether or not they had paired to a Shield before, by simply sending a negative session ID. And this gave us full access to their people's computers. And we actually did, at that time, we ran a port scan of the entire internet to see what computers were vulnerable, and came up with a list of, I think it was around 10,000 IPs of computers.
How much money is that worth? On the black market, how much money is that worth?
I honestly don't know, but my guess is quite a bit. People pay, many thousands of dollars for, 0 days on like phones and stuff. My guess is this was worth quite a bit, but we did not try to sell it. We disclosed it to NVIDIA, and it's been patched. as well.
I'm
But
really interested in that. How does maybe it's an aside, but how do you disclose it to NVIDIA? Do you just send an email to security@nvidia.com?
kind of, yeah, they have a bug bounty program
What
similar
is
to other
that?
companies. A bug bounty program is basically where a company that produces software or even hardware companies do it. They will generally pay money, some amount of money for security vulnerabilities if you disclose it to them, give them time to repair it before you go public. There's like basically a period of time, I think it's, I don't remember if it's 6 months or some number of days or something, where you're not supposed to publicly disclose the vulnerability that you found, and in exchange they'll give you money. NVIDIA didn't give us money.
What?
But I know, right? They did not give us
What?
money, but we did disclose this to them, and they did fix it.
Oh,
But they
come on,
never gave us
NVIDIA.
money. I know. They, yeah. But that was by far the worst 0 day we found. We found some other minor vulnerabilities in their process, but the session passing a negative session ID and just having full access was the worst. But a little fun aside about us port scanning the entire internet. Turns out ISPs don't generally like when you port scan the entire internet. And so we started by using my own school's like servers and stuff to do this. And what happened was some other school, I think it was Michigan State. So a lot of, let me give a little bit of background for people that don't know. A lot of universities get IP blocks. So like an entire, subsection of IP addresses gets assigned to a single school. So for example, Case Western Reserve, where I went to school, had the IP block of like 129 point, I don't remember what it was, but basically it had the first 6 numbers and then it didn't have the other numbers, right? So like everything
Like
below that.
they get their own
So
postal code almost.
exactly. It's kind of like having their own postal code. And so what happens is if you just linearly scan every IP address, most of the time on the internet, that just hits random hosts. But when you happen to hit a block that is owned by a university, you're basically scanning every computer owned by this university. And, IT entities don't like it when you do this because usually it's for nefarious purposes. And in this case, the university of, I believe it was Michigan State University, sent an email to our university and was like, why are you scanning all of our machines? And so we got a email, us because it was coming from our machines and that was like, why are you guys doing this? And we were like, so turns out, fortunately at the time we were doing some, research project for one of our networking professors. So we were technically doing it was completely unrelated to any of this, of course. But we just said, oh yeah, sorry, we're doing a research project and our code accidentally scanned every computer, right? We just blamed it on having done it by accident. And then of course we put this on some AWS machines that we paid for and did the same thing to complete our scan of the internet. And that's how we came up with roughly 10,000 vulnerable machines.
That's just talking about publicly on the internet. Like if you put this on a USB payload and then had it just attack somebody from somebody else's machine, you could scale it up. I'm saying it's probably worth millions of dollars to a bad guy.
Yeah. Yes. Right. So we did it. We didn't try to like find, holes in firewalls and stuff like that. Right. We just saw whatever happened to be on the public internet. And yeah, somebody who's doing a more targeted attack where they maybe can get into like, some sort of subsystem, some sort of VPN, thing like that, could find, then everything is vulnerable. Well, everything running an NVIDIA graphics card. And
that's
I
like
imagine
you could literally penetrate the Hollywood movie industry. Like they have giant render farms, right?
Right. Assuming that those happen to be publicly
Yep.
available. Yeah. On the public internet. Yeah, we could. So that was, a nice little tangent we took on this. We actually got out of doing a project for our networks class by just writing a paper that explained this vulnerability. And our professor actually asked, because at the time, NVIDIA Game Stream didn't support just like streaming your desktop. They actually only supported like launching Steam and like and a few other games like directly. Like you could launch games or you could launch Steam. And so basically the most nefarious thing you could do was launch their Steam and then buy yourself stuff on their credit cards through Steam. Steam also has a browser, so then you could use a browser while on their machine and stuff like that. You could manually add things like your desktop, which would then basically work like a remote desktop machine, but that would have to be added to Steam. Now that support's been added to GameStream, and you can just directly, be like, oh, I just want to stream the desktop, and it'll do it. But back to our hackathon, where all this started. At the hackathon, we were able to then decipher how the communications all work and how to get the video and audio streams to start streaming. But we weren't really able to. We didn't know what kind of encoding they used or how to decode it or anything like that. And so we had video that was on a screen, but it wasn't. It was just like all gray with like what looked like artifacting. And what we thought at the time was that they were sending some sort of like AVI stream, like audio video interlace. What that means, where like they were sending audio mixed in with the video, and we were decoding them as if it was all one video or something like that. What was actually happening is that they were using some basically their own custom wrapping around H.264. So it wasn't just pure raw H.264. So we were decoding it as
H.264?
H.264 is a video encoder technique or software. It's like a type of video encoding. It yields pretty high compression rate. It's super common these days. Now there's something called H.265, which is better compression for these, like HDR videos and higher resolution and stuff like that. It supports HDR is also something. But basically, it's just a video encoding format.
So YouTube videos are probably H.264?
Almost certainly, yeah. So things like MP4, for example, like the things that people actually think are videos, is actually what's called like the packaging of the video and audio. For example, like an MP4 or something, or like an MKV, or these are actually a format that includes both a video and audio inside of it. And that video and audio may or may not be encoded together or separately. So there's something called audio video interlace, like AVI, if you've seen AVI video. That is where the video and audio are actually encoded together. But then there's also techniques for encoding just the audio and just the video. And then you package those two things together into one file format, which is where you get like MPEG. MPEG is usually, so there's something beneath it that's actually the encoding. Nowadays, the H.264 is one of the most common. And then the audio is encoded using some other technique. In NVIDIA's case, they use something called Opus, which is actually a pretty common audio encoding. It provides a lot of flexibility in terms of like lossy and lossless audio encoding. Similar to H.264 also does very good lossless encoding. But the reason I believe that H.264 was chosen in this case and why it's so common these days is because it's very good for streaming. Because the way it works is it has what's called P frames and I frames. And basically a P frame is where it sends the entire frame of video. Basically it sends an encoded version of every pixel on the screen.
Like a screenshot.
Like a screenshot, exactly. And then it has something that what are called iframes, which is what's much more common, which are basically, you can think of them as kind of like deltas between the frame you've just seen and what is the next frame. And so by applying that delta, you get the new frame. And so you can send down much less data than if you sent every single frame every time. This is why when you mentioned YouTube, I said it's almost certainly using something like this, though Google likes to use a bunch of proprietary crap, but maybe I shouldn't say that. So they might have something different, but it's very likely that they do.
Okay.
They also have Google made up that new WebM format, which I haven't dug deep into, so I'm not sure what it is, but they might use that on YouTube. I'm not sure.
Oh, I see. I think of WebM as GIFs with sound.
Yes, and they're all very commonly used for GIF with sounds. But I don't know if YouTube uses that or not. But anyways, this is what NVIDIA was using, which we didn't know.
How do you know that? Like, how did you even know that? It's just like now ones and zeros.
It wasn't exactly ones and zeros. So we use like Wireshark to packet sniff, right? And fortunately, Wireshark, and there's a bunch of other online tools that do similar things, but they allow you to basically take a blob of ones and zeros and try to decode it in different ways. And so we could set it to be like, oh, this is just, like just try to decode this as TCP. See if it's a TCP packet. See if it's an HTTP packet. See if it's right. And you could then choose different things and eventually get something that looked like something, right?
Okay.
And that's
It's
sort
like,
of how we did it. It was a lot of trial
it's
and
like
error of just using common formats.
like if people only ever picked passwords from a set of 1,000 passwords, and you just had the list of all passwords.
Kind of, yeah. It's similar, but what we ended up finding was that in the metadata, right, the way we determined what the actual audio or video and audio streams were was from the metadata, because as you said, the actual video and audio, no matter how you try to decode it, would still just be ones and zeros unless you were decoding it as a video, right, which you can't do from like a packet sniffer. But what we could do was decode the metadata. And so we kept on doing a lot of trial and error on the metadata, and seeing that it would have like, oh, there's this number that like counts up to like this other number, and like, but like every once in a while it like, does this. And like what we would find out is that this was like, as I mentioned, there were like P and I frames, and so it'd be like every time it would send 10 iframes and then 1 p frame, and like it would have the index of each frame as it was sending it and stuff like that. And so that's how we ended up determining what the video source was from looking at all of this. And you can tell, Wireshark. I'm going to keep saying Wireshark a lot because that's what we used. But I'm sure there are other packet sniffers like Charles, for example, which you can do something similar. But we would say like decode this block of data as like this, and you could like name different bits. And so like as we started figuring out what each byte sort of represented, we started building our own terms for things. And like we would basically be like, all right, this bit that we don't know what that is, that's garbage. And we would just name it garbage and like keep. And so that way we sort of categorize things. And that was also how we figured out the controller, right? Like how they were mapping key codes and stuff. There was clearly a stream, and like when I would push a button, this value would change from like EF in hex to like AC. And so then we would like write this down. We'd be like, all right, X button, is this. And like we would do it like 100 times because lots of things were happening in the stream. Like, all right, that's the value that's changing when I'm pushing this button. And then when you like the harder ones to figure out where the joysticks and the triggers, because they're analog, right? And so we had to kind of figure out how they were packaging those, which turned out not that complicated if you know about it, but they were just using it was like a 2 byte or thing, but it was reversed, because they were doing, I don't remember if it's big endian or little endian, whichever one when they're reversed is. And so that one took a little bit of figuring out because it was backwards, or seemed backwards. But
probably little endian.
Yeah, exactly. But once you had like everything else figured out, that became pretty easy. So
this sounds like solving a crime. This sounds like basically solving a crime like a detective.
A little bit, yeah, exactly. So you sort of start piecing together the things that what they are, and the other things you kind of throw in this bucket for later, and then you just as you learn more and more about the things that you think you start to be able to guess what the things you don't know are. And so then, one of the things we also had as a sort of a benefit was that there's only a limited number of things that the hardware on the shield itself could do, right? Like we had to use something that was that the hardware on the shield could decode, right? And
what
we knew they
what was the hardware on the shield?
So like the SoC they used was a Tegra 3 or 4, which was an
SoC?
NVIDIA SoC, is a system on a chip, like the CPU and graphics card. So nowadays CPUs also include graphics processors instead of like a separate graphics card. And so they're called SoCs. They're a system on a chip. It's like when you have multiple, like a full system on one piece of silicon. And the SoC they used was an NVIDIA, of course. Tegra is the name. So Tegra is, for those of you who have heard things, is like if you think of an Intel i7, for example, the i7 bit would be. So this is like an NVIDIA Tegra. I think it was a Tegra 4 or 3 at that time. I think Tegra 4. Don't quote me on that. And, they've made many new ones since then. But the chip had, a limited number of things that were on the hardware. And also it was running Android. So Android only supported so many things in terms of encoding and decoding. So this is how we sort of narrowed down the possibilities to, what was available on the encoding or decoding side of things, as well as it is public information that the NVIDIA graphics cards have a hardware H.264 encoder, right? Like this was like a thing that they published because this came out, so GameStream came out the same time that they released what they call Shadow Play, which is a similar thing, but where they basically record your own screen as you play, and then you can be like, oh, save the last like 5 minutes of my gameplay for gamers to do. And then now they've even added like streaming. You can stream directly from that, to Twitch or whatnot. But because we kind of knew that they had these things built in, that's how we were able to narrow down, from like everything possible on the internet to, it's got to be one of these, 3 or 4 things.
This is, I keep thinking there's like intrigue, there's mystery, there's money involved, there's hacking. And this last bit might as well be like, I saw a footprint, so we know the guy is like 6 foot. Like,
yeah, a little bit of that. It's interesting. Now we were talking. I was talking to Cameron a while back about like whether or not we think we'd be able to do the same thing nowadays with like the current version of everything, and we both kind of agreed that we can't. NVIDIA is now doing much better security practices and stuff. They're using HTTPS. And like, we had to figure out how their SSL handshake worked when they added that, because pretty much every feature or every version they would, change their protocols, they would change something and break our implementation of it.
So you two roommates who are undergrads are in an arms race with a $1 billion company. How much money do they have?
Yeah, it's in the billions. I'm not sure exactly how many. But yes. The best part was for a while we had better performance than they did, because now.
So Diego,
now
I think you've been tiptoeing around something. What is it?
Yes.
Like, what was the hackathon project? What are we talking about?
What is it? So it is something we called Limelight, and we called it that because NVIDIA's dream, and this was like kind of being in the moonlight, the moonlight of something. So like in the limelight. And there's actually, turns out there's a good song by Rush called Limelight. So that became our theme song, just because we're nerds and like to listen to Rush. But yeah, the project was called Limelight, and we didn't actually win the hackathon, but we got some recognition for it. And then Limelight became an actual app. That was we published on the Google Play Store and eventually on the Apple Store as well, on the Apple App Store. And that was when we started getting a little bit of recognition because people started downloading our app and stuff, and we put up a website and everything. And then something kind of interesting happened, which is we got a email from the legal department of a company called Limelight Networks, which turns out, funny thing, I believe their headquarters are here in Mountain View. I've seen their before, but they, I'm not sure if that's their headquarters, but I think they had an office in Mountain View. I've driven past it. But anyways, they, this company, turns out they do video streaming, which is, yeah, exactly. They're just like some sort of media company, but they do something that was similar enough that they filed a cease and desist on us for trademark infringement on their Limelight Networks trademark. And, we were college kids, so we were like, fuck, we're going to prison. We're going to like, we're so screwed. What do we do? Like we're kids.
Oh, man.
And so then, of course, we just immediately were like, yeah, we're so sorry. We'll change the name, blah, blah, blah.
Did they say, aren't you the same kids who were port scanning the whole internet?
Yes, we are the same kids who were port scanning. That's true. but so we ended up changing the name to Moonlight. And the reason why we picked Moonlight was actually because that was the name of our senior project. So Cameron and I did a senior project class, and we decided we were going to build game stream for AMD graphics cards. So at the time, this, only NVIDIA graphics cards had this game stream. The Shield only worked on NVIDIA graphics cards. And we were like, what if we built this for AMD? I don't remember what the AMD graphics cards were called at the time, but they had just come out, and they also had an H.264 encoder built in. And to this day, they do.
Was it the Radeon?
Radeon is the whole line, but I don't know which one.
Oh, which one? Okay.
Yeah. So in theory, we were like, yeah, they have the hardware. You could probably write some software to do this, but nobody had. So we did. We wrote a Moonlight server, or we called it Moonlight because we had Limelight, and then we had Moonlight for AMD cards, and then we got the cease and desist. So we renamed our NVIDIA project to be Moonlight. And it turns out the code for Moonlight still exists. It's in we have a private repo on GitHub, but we actually did succeed at building a AMD powered game stream, and it actually performed extremely well. The AMD hardware did very, very well at streaming, and the only reason why we didn't make it public or continue working was because we didn't implement any kind of security behind it. There was no pairing. There was no, no exchange of keys. Literally, like, if you're hosting this, anybody can connect, and like you can do all sorts of crazy things. But so we were like, nah, not going to show this one off.
Only you and Cameron were friends with a business student while you were undergrads.
Yeah, right. So we were asked, because of the senior project, we were actually asked to present it at a one of our school's like engineering events, where like all of the alumni come in to see, what's the engineering department up to, like what research. And so we went and we showed this off, and at the time, we actually did something that is very unsupported by all platforms, which is we put a NVIDIA graphics card and an AMD graphics card in the same machine, and did some wild hacks to get both of them to stream to different devices. So we could, from the same physical desktop, show off two different games streaming at the same time to two different devices. And neither AMD's nor NVIDIA's like platform support this. This was just some crazy hack we did at the time, just to show off and be like, look, this is like the product that this company makes, and this is like the thing that we built. Showing them side by side, and it worked pretty great. People were super impressed. It's kind of hard to explain all of this, what all the science behind or I don't know if you can even call it science, but all the tech that goes into this without having a long conversation with someone. So it's kind of neat that we get to do this, because
we have all the time in the world, Diego. This I'm not lying when I say this is like a thriller novel right now.
So we got to show this off, and there was some people who like kind of understood, who were like in the space, understood what we were doing, were like super impressed, and like some people who had like no idea were like, whatever, these kids are just playing video games, right? Like, so by this time, roughly a year had passed, and once again there was the Michigan Hackathon. We went there, and this time around they had we did something totally different. We didn't do Moonlight for this hackathon, but they had decided to create an award and name it after us. They actually, so they gave out a Limelight Award, which was an award for the hack that became an actual thing, for like people who like kept on working on whatever their hackathon project was and like turned it into something. And so they gave this out. I don't know if they still do. They probably don't anymore. They probably did that for like a year or two. But while we still haven't won anything from MHacks, we did get an award named after us for building this app. And this app is now available on like all platforms that you can think of,
Is it still
including
called
some.
Moonlight?
It is still called Moonlight. We have a website, moonlightstream.com, and it's actually available on platforms you wouldn't expect as well. So along with your Android, iPhone, PC, Linux, Apple, whatever you have it, it's also available on like Raspberry Pis. People have put it
Oh.
on, people run it on Android TVs. They run it on all sorts of. There's also some that some ports that we didn't do. We didn't do the Raspberry Pi port, for example, but they're out there. People got pretty excited about this. It's all open source. All of our stuff is open source. So,
Why hasn't NVIDIA or AMD bought you out yet?
That's a great question. And honestly, I don't know why. Probably because we're giving them free software right now. We're giving them like free sales. So like, I think to them, because they could also shut us down, right? Like they can change the protocol in a way that we can't copy if they wanted.
Right.
They almost did. They added a new like login system to GeForce Experience, but they made it optional. So you don't have to use their login. But they could have added their own proprietary thing. And then, there's no way we could copy it. But they didn't. They're actually playing kind of nice. And I think the reason for that is because there are people, NVIDIA's game is selling graphics cards. They are not in the market of selling these NVIDIA Shields, right? Like they don't make their money from that. They probably sell them at a loss, to be honest. The hardware in them is quite high end. So I think that they get a lot more graphics card sales because we provide a free open source version of their software that people can buy. So like someone is like thinking, I don't want an AMD, I don't want blah, blah, blah. And like they know that they could play games, on their iPhone if they go with an NVIDIA graphics card, right? So they'll buy an NVIDIA graphics card. And, maybe that's, gives them, I don't know, 0.1% of sales or whatever, right? Like who knows how much that actually affects them. But it's probably more positive than it is negative for them to have our software exist. And so that's why I think they
Why not hire you? Why not hire you as an independent contractor or something?
I think the reason for that is honestly because they don't really have their shit together, is my guess. I'm going to tell a short story about the next year I went to, or not the next year, several years later, sorry. I went to Google I/O. And you'll never guess who I happened to meet at Google I/O, if not the manager for the GameStream team.
Oh, no
that
way.
built the original GameStream.
Wow.
And I actually talked to him and I was like, dude, I like wrote this software. And he
knew
like
you.
totally, he knew me. Yeah. He knew who I was, or, my internet persona, and like knew that this existed. And so I asked him, I was like, first of all, did you guys intentionally break our shit all the time? Because they would, like pretty much every update, they would change something that would break it. And he was like, because it was also backwards incompatible with their own version, right? Like if they didn't update, if users didn't update their own clients, they also wouldn't work.
Right.
And so I asked him, I was like, were you guys trying to like do this to break our software? Like if this was, just their attempt to shut us down. And he basically was like, no, we did that on accident. Like most of their backwards incompatible changes were on accident, according to him. And I won't say his name because I don't remember. But if he ever hears this, I'm sorry, I don't remember your name. But basically, yeah, from what I understood, the way they threw that team together was very sort of ad hoc, like they didn't put a lot of investment in it. And he said they took a bunch of people who had never done this before, this type of work, and just threw them together on a team and told them to build it. And so they didn't really have experts in the area of streaming technologies, of building this. And so I honestly think that the reason why they didn't come after us or try to hire us or anything like that is because they just were a very low budget project. They did not put very much resources into this. Once again, probably because their game is to sell the graphics cards.
Right.
And this thing is like a gimmick for them to try and sell more graphics cards. That's my guess. But it's funny you asked that, because while NVIDIA did not try to buy us out, another company that some of you might have heard of did. Sony came to
Oh,
us.
what? Sony is so much
Yeah,
bigger than in India. Nvidia is
Sony
just cards. Sony
is
is
so much
like
bigger.
everything.
Yeah, so they came to us and they wanted us to build game stream for the PlayStation.
I would like
Um,
that. I'm a PlayStation person.
yeah, I don't know if you've heard of something called PlayStation Now or PS Now, but it is their version of this. They run games on their servers and stream them to your PlayStation 4. That is what they wanted us to build now, 6 years ago or something?
Mhm.
Um, and they contacted us and were like, we'd like you to do this. Can we, we'd like to, have a talk. Basically, we had a Skype conversation, which was essentially the interview. Like they didn't interview us. They just gave us, we had a Skype conversation, and then they gave us an offer. And we're like, come work for us. And they wanted us to, their headquarters, or not their headquarters, but their office was in Orange County, I think, California. And we were juniors in college at the time, for
Oh
our third
man.
years, for those that don't know what junior means. And and they thought we were grad students. So over the phone and stuff, they were like, oh yeah, you guys can just like drop out and come work for us. Like stop your program. Because they thought we were already had degrees. We were just doing like PhDs or something, just like, much, much older than we were. And we were like, no, I kind of want to have a degree. Like, I haven't finished this thing. So we actually ended up turning them down so that we could finish school, because they wanted us to drop out of school.
Wow.
Yeah, because we told them, we were like, oh no, we're not grad students. We're still in undergrad. And they're like, you know what? That's fine. Just come anyways. Um, and we were like, no. But this was, all of that happened in like a course of like a week, maybe 2 weeks. But it was some of the most like stressful times of my life, where I was like juggling these different things. Because at the time I had already accepted an internship. I thought that was like literally the worst thing ever. Was like I would never be hired if I rescinded an offer.
Man.
Now as like an adult, I'm like, yeah, I probably could have done that and nothing would have come of it. But at
I
the
hope,
time,
I mean, this is just an aside and there's plenty of story left to go, but I hope part of this is self-realization in your own worth.
a little bit.
Man, it's always the smartest people that I talk to who are like, maybe because things are generally obvious to them, they don't think it's hard. So they don't value themselves as being smart. Maybe, I don't know.
Yeah, that might be. That seems very plausible. I would believe that if I read it in an article.
So anyway.
So anyways, we ended up turning them down. And they did, I guess they eventually found someone to build it, because it exists now.
Right.
But it originally came out, a different version of this came out for the PlayStation. Oh crap, what was their little handheld thing called?
Vita.
Vita, exactly. That was where this originally came from. Or their original Sony's original version came out for the Vita, where you could stream games to your Vita, which is almost
That's, yeah, it's the same thing.
exactly the same thing that what NVIDIA did. Now they have it similar to NVIDIA Grid. So I believe NVIDIA has literally been at the forefront of all of these technologies, and like all these companies are now copying them. But NVIDIA Grid, which is now the same thing as Google Stadia, which is spending a horrendous amount on advertising because their ads are everywhere. And PlayStation Now, which is they have server farms, and then they stream games to your device. And NVIDIA had this, it's called the Grid, NVIDIA Grid. And then now PlayStation Now has it, or Sony has it, it's called PlayStation Now. And Google developed the same thing called the Stadia. And basically all of these things are based on the same technology. And whether or not they use NVIDIA's, graphics cards in their tech stack or not, it's kind of a moot point. But basically, like they pioneered this whole idea of like you could put all of this hardware into the graphics card, including a like network stack and stuff, it actually circumvented, you know, a lot of CPU stuff by being able to communicate directly to the network chip. So like once you started the stream, there was almost zero CPU usage as far as like maintaining the stream and stuff. It just was all done on hardware on the GPU. And that's how they achieved extremely low latency streams. We actually did some, we have in our app now that you can download. We don't have it on iOS, unfortunately, but on Android, we actually have stats that tell you, you know, the network latency, the decoding latency, you know, the different latencies, and you can get end to end, you know, everything depends on your network, of course, but if you have like Ethernet and you have a high-end device, you can get like sub-frame latency, like under 16 milliseconds for a 60 frame per second stream. So you're streaming, you know, one frame behind or, you know, half a frame behind. And that's, you know, way lower than human perception for sure. For that, you can basically play any game at that point. It is a little cumbersome if you're using a controller to play, you know, a mouse and keyboard kind of game. But, you know, nowadays phones support keyboards and mice even. So you can just do it. And even if you're not a gamer, you can use this for just super low latency remote desktop. And we've actually had contact from different, we get emailed, our email is, you know, not public, of course. And so we get emailed all sorts of things, including companies that want to make, you know, competitors to like VNC or Microsoft Remote Desktop or stuff like that, to do, you know, lower latency, just remote desktoping. And the, it works really well if you have a solid connection. It's all based on like UDP streams and stuff, so it's super lossy. So if you don't have a good network, it just, you know, it's way worse than the alternative. But if you do have a strong network connection, you're not, you know, like really far from where you're streaming from, it's, you know, imperceptible, which is how, you know, companies like Sony and Google and even NVIDIA are getting away with doing things like Stadia and Grid and stuff, is that you can get this super low latency.
Is streaming the future for gaming?
I think so. I think I go back and forth on it. I think because esports are becoming so popular, right? Those kinds of people who are really serious are always going to want their own hardware, right? Because it's, you know, they have reaction times that are super small, and they think that they need 200 frames per second because they can see, you know, these minute things, or they can react to them whether or not they can see them. And so they're always going to want as fast as possible. They're not going to put up with even having, you know, a few milliseconds of latency due to network plus encoding/decoding, right? So that market's always going to exist, and I think there's always going to be people who, you know, who are, I'm going to call them enthusiast gamers, you know, the serious gamers who aren't, you know, actually professionals, who are going to, you know, be the, you know, PC master race kind of people, and they're going to have their own hardware. But I do believe that it's going to become more and more common where streaming games is utilized. Companies still want to sell hardware, right? Like they make a lot of money selling hardware. So I think things like, you know, like the PlayStation 5 is coming out now, right? And
it looks like a PC, to be honest.
Yeah, it does. It's also huge. But I'm fairly certain it's going to have capabilities of playing, you know, PlayStation 3 and PlayStation 4 games simply because they have streaming with PS Now, right? Like I have been playing a PlayStation 3 game on my PlayStation 4 because they allow streaming. And whether or not that's just like the future of all gaming, probably not, to be honest. It is, it might become the future of like mobile gaming, where you're like, or I don't know if mobile is the right word, but of like, you can do remote gaming, right? Like you can go on a trip and then like you're stuck in your hotel room because it's raining outside, and so you can play your game. I think that's going to be where it shines. But you really want the proximity to the physical computer is important to have lower network latency. So, for example, if I try to stream, coast to coast in the U.S., it's going to be impossible. The stream is going to be so bad. There's going to be so many drop frames. It's going to be super delayed, right? Like it just, it's totally unplayable for most games. You might be able to play like Civ or, some other turn-based game. Maybe. You're not going to be super happy about it, but like, nothing happens if you can only click once every 3 seconds, right? There's no reactionary things. But, beyond that, you're just not going to be able to play. So what I think is going to happen is things like these server farms, Stadia, Grid, Yes Now, etc. These are going to be more common because they move your desktop around so that you can do streaming, right? So I can just have my phone or my my laptop, and I can still play all of these high-end AAA games that will run. Also, what in my opinion the best part is I can play PC games on my Apple MacBook. A lot of games nowadays are cross-platform, but still several are PC only or Microsoft only. And so that I think that's one of the biggest benefits. Like I can carry around a laptop and then use all the power from my desktop. But yeah, no, I think that games it's still far off before this sort of becomes like the standard. I think quote unquote real gamers are they're still gonna want desktops. I mean, I think it's a similar thing to asking like, are phones the future? Are people going to just stop having computers because their phone can do everything? And I think that it's a similar point where, there's just some things that just feel better. You can do it better on a computer, even if you can still do it on your phone.
Yeah, I think the analogy that comes to my mind is something like some people still buy physical copies of games versus I think most people now buy digital copies. And then fundamentally changes the purchasing model. Like you will lose access to a license as opposed to, a physical disk that you can always put into a hard drive.
Yeah, exactly. I mean, you mentioned the new PlayStation. I don't know if you saw, they even have a version that doesn't have a disk drive.
Digital only.
Digital only, which, it's kind of crazy to think about. But then I think about my MacBook, and like Apple removed the disk drive in MacBooks like several years ago. And I have not, I obviously haven't, I've never been like, oh crap, I wish I had a disk drive, And I honestly prefer downloads on my PlayStation as well because they're faster. The disc reader is slow. So like launching a game that it has to read from the disc, takes like, I don't know, let's say 20 seconds instead of like 5 seconds for launching a game that's installed directly on the hard drive because I downloaded it. And, this is like certainly not a significant amount of time that it waits, but like, my eager, anxious, want to start playing, right? I even put like SSDs in my PlayStations so that I don't have to wait for the loading screens. Just because.
I mean, it lines up with your personality of chasing that near real time or faster than real time, which is something you've been doing forever. I have a natural question. I've been thinking this for the last 5 minutes. What's the future for Moonlight?
What's the future for Moonlight? It's in what I'm just going to call like keep up with NVIDIA mode. Basically, anytime new technology comes to the NVIDIA's game stream or comes to the devices, for example, iPhones recently added mouse support and keyboard support and stuff. And so we added that to Moonlight because the stream, right, the stream protocol has supported mouse and keyboard since day one because NVIDIA built it that way. But Mac or Apple iOS didn't support that. Android has supported it. I don't remember which version added support for that. I think it might have been just going to make a fool of myself, I guess. So I don't remember,
That's
but
fine.
It's been years. But iOS recently added support for mice. So we've been able to add that to Moonlight. So that's sort of the thing is like we add more. They added 4K support, so we added 4K support. They added, here's a new one, 120 frames per second. So they have these new
VR.
So maybe VR. We don't have any VR support yet, but the new iPads, the iPad Pros, have 120 frames per second screens, and a lot of Android phones have 120 frames per second screens. So now we support 120 frames per second. So that's the kind of thing that we're doing, is just adding more support. There is somebody who has created a spin-off. I believe it's called Sunshine. I know, right? Which is intended to do multi-stream. So this is a feature that NVIDIA does not support, which is one person. So only one person could be playing, right? That kind of only makes sense. But multiple people could be watching the stream, right? In fact, there's no reason why they couldn't stream that, as much as they wanted to. But they don't support that. So that's one of the things that Sunshine is trying to add support for, is creating. But to do that, you have to create the server side, right? You have to create the software that runs on the PC. We couldn't just piggyback off of NVIDIA software.
So it's
because they don't support it, right? So we actually did this for the original Moonlight, which was AMD. We actually had support for this because we didn't do any kind of authentication on the stream. Any number of people could connect to the stream. And so, we actually had this guy reach out and was like, I'm trying to work on this. Do you guys give us any help, blah, blah, blah. And we were like, here's our, we gave him access to our private repo so that he could take a look at how we implemented the original Moonlight server. And how we did it so that he can, hopefully this becomes a thing. But yeah, he claims it works. I think I would consider like beta. It's not fully fleshed out yet. But it's going to have multiple stream support. And he could even add multiple controller support, right? NVIDIA doesn't currently support that, but there's no reason why not.
Have you thought about just making your own company?
Based on this?
Yeah.
No. Well, yes, we've thought about it. We've kind of decided against it for a couple of reasons. One of the reasons we decided against the original reason a long time ago was basically we had jobs. Like, we're not doing this for the money. This was for fun. Once you do something for money, you kind of have to take it seriously. We get hundreds of emails. There's like a Discord server that's exploding with content all the time. People are talking. And asking for help is the biggest thing. And like, if you start to sell a product, there's a certain amount of expectations from your customers, right? They expect to be able to like file a support ticket and get a response, right? When we do this for free, when someone badmouths us, right, we can badmouth them straight back because like we're like, we can literally say, look, I do this on my own free time. I can only work on it on weekends, blah, blah, blah. You're going to have to just, figure it out on your own, right? Like, we can say that. And we say that occasionally. We try to do what we can. But occasionally we literally just say, because like a lot of times we'll get people who are like, oh my gosh, this issue has existed for like 2 months. Why isn't this fixed? Right? And like stuff like that obviously if something's like broken, we fix it. But this is often like, oh, there's like stuttering on this specific device. There are some devices, some phones with different configurations and stuff that end up having issues. Sometimes the Bluetooth antenna fucks with the Wi-Fi, and so you get stream jitter and like, so we, every once in a while we add settings that allow you to tweak some of the things so to try and fix it for specific devices. So people will like be like, how have you not fixed this? My, I don't know, Samsung, whatever, phone that I bought, is having this issue. And we will just be like, dude, look, we do this on our free time. Like, this is 100% free. If you want a company you can bitch at, go buy a Shield, right? Like, so there's that aspect of it. And then there's also the question, which I could probably get answered, but as of now, it's still an open question of like, would we get sued by NVIDIA if we tried to, monetize this, right? Like, is the reason, because I'm certain at this point, NVIDIA knows about our project, right? And so
They
they
better.
are. So they are allowing us to exist. And the question is, if we put a dollar sign next to it, what would happen?
Okay.
I could probably go and like talk to a lawyer and like find out like if they would even have any grounds or like, like is anything we're doing actually illegal? Technically, reverse engineering is not illegal. The only thing that is illegal is like if you reverse engineer something with malicious intent, something like that, or if you use it to do malicious things. But reverse engineering itself is not illegal. And so like, as far as I know, we haven't done anything actually illegal. And so they don't have any grounds to like sue us or anything like that. But if we started monetizing it, that puts you in like a sort of a different category, right? Of like, is this like IP theft or like, kind of stuff like that. But, I could probably get a lawyer to answer that, but we don't know. And we don't really want to figure that out because as I said, we have jobs, we're happy. We do this as a hobby. And like, I don't know. Would it be the same if we did make money off of it, right? Like,
I don't know.
I guess I haven't said this. I should probably say this by now. But we have well over 1 million downloads.
I was going to ask you how many users you have.
Yeah, I don't know how many users off the top of my head, to be honest. Turns out our users are very passive and like they're not super active because this is something. Even me personally, I don't use it like every day. This is like a thing you do every once in a while, right? So like our 7-day active users is pretty low. Our monthly active users is medium, but then like it drops off pretty quickly where it's like people use it every once in a while, right?
Give me unique numbers. Let's say total unique users, which is 1 million downloads, is a good.
Yeah, so like all I know off the top of my head is downloads. We have over 1 million unique downloads. Across our platforms. We had over 1 million on just Android. iOS is something in like 500,000 range. And unfortunately, we don't actually know how many users we have on our other platforms. I think we did add Google Analytics to it to try and keep track of that, but I haven't looked at it in forever.
Okay.
Because we're not, these are just fun numbers, right? We don't do anything with this information. Other than we use these things mostly to track crashes.
How does the community view Moonlight? Like, are there expectations? Are they okay with this fact that you don't want to monetize it? Like, are there stances, open questions?
Most people are very okay with the fact that we don't want to open this. This is a very, I would say the community is super like helpful to each other. And like, there's a lot of people that want to get involved in just helping to maintain sort of the community itself. Like not that many people want to contribute like code wise. There's a few, but not that many. But there is a lot of people who want to just like help other people to like get set up or just talk about issues that come up or like just chat about technologies that are being launched. Example, Apple adding mouse support, things like that. So the community is fairly active. They don't really request that much from us. And we do have several people who do help us and go, hey, these people do this out of the kindness of their hearts. Don't be a dick, kind of thing. So that's actually pretty nice to see. So I would say the community is pretty. You get like some people hop in just because they have this one problem. You fix their problem, you never see them again. But right. a lot of other people are like super active and just like literally chat with each other as if they're friends. Whether I don't know if they know each other in real life or not. I assume most of them don't, right? But they do talk to each other just like all the time about just like oh, what games are you playing? Blah blah blah. Like what's going on? That happens quite a lot.
I actually have another friend who was fairly top ranked in Age of Empires. I think top 5 or something in the US, and he went on and on about Moonlight once.
Oh yeah. Yeah, Age of Empires would be a good game to play with Moonlight. That one's like just, it's not just like entirely turn-based, but it's like, slow enough that if you drop a few frames, it's okay. Because that's the thing. You don't want to play like first-person shooters or get really difficult to play unless they're kind of slow. We used to play our test game was Left 4 Dead 2. That was the game. I don't even remember why we chose it, but that was every test ever. You can even find. We had to put up a tutorial video when we launched for the Apple App Store. I'm gonna segue in a little bit into talking about Apple. But when we launched on the Apple App Store, we had to have a video that showed how the app works.
Okay.
And so we put together this video. I think we finally updated it now because it was very out of date. Like the app that we were showing was like very different from what the app currently looks like. But like, the core functionality was all the same. And even in that, we showed off how to play Left 4 Dead, and I did it on an iPad. But to talk about Apple for a little bit, so
By
their
the way, let
review
me set some
process.
context. Let me set a context for the audience. You are a diehard Apple fan. Like you love all Apple products and you buy them all the time. But having said
That's
that,
very true.
go on.
Yes, that's very true. I am currently looking at a MacBook Pro, sitting next to my other MacBook Pro, sitting next to my iPhone, wearing Apple EarPods, EarPods Pro, because the AirPods that I have are sitting over there. And I have an Apple Watch. Yeah, I love Apple. No, but I'm going to talk bad about their review process a little bit because they. So the first thing they did was something. They have really strict restrictions around things like encryption and now they've added a section about doing like streaming and remote desktop type applications. But one of the biggest issues that we've had with them is that they need to be able to test our app, right? But their reviewers don't have a gaming desktop available to like pair with and stream and like do all this stuff, right? Like, and so the question is, how do we provide them, right? Because they are not allowed to just not be able to log into your app. You have to. So for most apps, you have to provide them with like a login credentials, right? Like Facebook or whatever, they provide them with a fake account that they can log in, right, and do whatever
Oh,
testing they need to
interesting.
do. Exactly.
No
And
idea.
for most apps, that's you just give them a username and a password to some random account, right? But the question is, how do you do that when you need to give them hardware? So we are somewhat clever people, and so what we decided to do is we provided them with a desktop that we have man in the middle. So we took one computer and paired it to another one, and then that computer that's now in our man in the middle provides the entire stream, everything without the pairing process. So it's just like already paired to the actual host machine. So then we provide them. We had to provide them with the host name and stuff of this server, and so that they can do their testing, so they can connect to our machines. This is something we own that has to be available on the public internet. Also, yeah, listen to what we had to do here, right? Like we had to expose one of our machines to the public internet with no kind of security so that they can test it. And we were a little clever. We're using like a virtual machine on like on a desktop, so that if literally the only thing on it is like one game and NVIDIA software, right? So like they can't, if someone does decide to hack us, like they'll hack some virtual machine that has nothing on it. And now recently Apple pulled a fast one on us. They've added a clause to their testing that says that if it does this kind of remote streaming or anything, it has to be on the same LAN, the same network. And so now we're like, well, how the hell do you guys want us to provide you with a PC that you can remote into on your own networks, right? Unless you have an NVIDIA graphics card in a desktop running Windows, like set up to do this. Like, how the hell are we going to provide this for you, right? Because like, for I guess their idea is like if you provide like a like a VNC or a remote desktop software, you go, oh yeah, download this software onto your PC and like run it and stuff or whatever, right? And that's much easier. And then they can do everything on their own LAN. But like for us, it's like you need hardware, like special hardware to do this. You can't just and run this on whatever. And so now that we're still waiting to hear back from them.
Are they trying to shut you down?
They're just not letting us update the app, right? Like we can't publish a new version. And so then we were literally like, how do you want us to comply with this section and this other section of your guidelines that like say that we have to do this way? And yeah.
How does the Google Play Store test it?
They don't. Google's review process is significantly less thorough than Apple's, I would say. They mostly do like static analysis type of thing, like scan it for viruses type of thing. They like, I mean, I don't actually know what they do, but these are the kinds of things I think that they do. Is that they just like scan it for viruses and like run the app and make sure it doesn't spin up a background service doing some naughty things, stuff like that. And possibly somebody, has tried to stream once or twice to our box because it is still available even for them, right? But we haven't. Their process is just like significantly less intense than Apple's. What's interesting though is that we have like logs from when our server gets hit, and so we've like seen we know when they're testing our app, right? Which is actually kind of funny because we'll like see them testing our app like at like weird times that aren't when they say they're like reviewing our app, and we're like, like what's this guy doing?
Oh man, this is such a fascinating world, and I think now we're getting into more like basically app development. And like, do you have other apps on the? I've had this question for the last 40 minutes. Like, is Moonlight the only app you work on?
Moonlight is the only app that I personally work on.
Okay.
Cameron has a few other apps that do some interesting things. They're all very nerdy. So he's got like so a lot of his apps are kind of dated now. Oh, here's a cool app that we have that's actually Moonlight related. We have an internet testing tool that we publish so that it'll basically like check your ports and stuff and try to guess at why your streaming setup is not working.
Like a diagnostics.
Yeah, exactly. So I say we, but Cameron built that one all on his own. And we just published that to help people because we would get questions all the time like, oh, blah, blah, this isn't working. And we'd be like, did you forward this port? Like, did you? Right. So now we have a tool that'll be like, oh, we're on the same network, so it works, but like this port is closed from the external network, blah, blah, blah. Right. Like stuff like that. But we also had some other tools that he's published. One that's called Remote ADB, which is kind of cool. It's an Android app that lets you, ADB is called the Android Debug Bridge, which is a utility that basically is what you use to debug an Android phone and also to like publish a game to it or to like read files on it and stuff. It's just like a debugging bridge for Android. And he built an app that lets you do that to another phone. So you can like remotely debug from one phone to another phone. So you don't have to do it from like your computer, right? Because like remote debugging is a thing that's supported by Android. So you can, debug over Wi-Fi, or I guess you could even do it at Bluetooth at one point, I think. I'm not sure. But you can do it over Wi-Fi or, USB is the most common. But he built one that does it over Wi-Fi, but from a phone rather than from your computer. So that was, just so that for funsies, basically, you could debug an NVIDIA Shield from your phone was what we used it for. But it's on the App Store or the Play Store. But yeah, I do not have any other apps.
All right. I guess generally I do like to end with this question, unless there's other things, which is, is there stuff that you hope would come up and hasn't, as a line of me asking questions, like something left behind, something you want to talk about?
There is one question that I kind of expected you to ask, but you didn't, which is like how the team, like a group of people that have worked on this, like how it like has changed over time, which I mentioned, I've only mentioned myself and Cameron, but there were actually other people who worked on this with us as well and who are kind of not working on this with us anymore. But some of our other friends and kind of roommates at the time in college worked on this at our hackathon projects. But then they've sort of taken more of a backseat role in this. But we still have everyone listed on our contributors page on our website. Everyone who has ever, done something for us. But yeah, we did have a couple other friends who worked on this. But now it's mostly just Cameron, and I do a little bit. Just, people grow older and get busier.
Life.
Life, people move far apart from each other. And so it's just like hard to maintain relationships when it's on the your chat, right? But yeah, so we're still we're all still friends, but we don't all work on this anymore.
Gotcha. It definitely sounds like I had the chance to have this conversation at a fairly mature point in both your and Moonlight's lifetime.
For sure. Yeah, it's gone all over the place.
If we posted this recording with the community, would you want to say something to them?
Ooh, I hadn't prepared for this one. I guess I would just say thank you, for everybody who has used it or is interested in using it. We did this originally just for ourselves, but then everybody got so excited about it, and we were like, it blew up way bigger than we ever imagined. When we were doing this hackathon project, it was 100% just for shits and giggles, and now it's an app with I don't know how many active users, probably thousands of active users is my guess if we have millions of downloads. And so, yeah, it's amazing. Also, all of the people who have contributed to make other ports of the app to other devices and stuff, those are super cool to see, and very inspiring. A question that I thought you would ask me that you didn't was when so we port scanned the whole internet and stuff, and I got all this list of names. You never asked me if we ever hacked into any of them.
So did you try to hack into any of those 1 of 10,000 machines?
So we didn't hack into any of those machines exactly. But what we did do is before we port scanned the entire internet, we port scanned my entire campus. As I mentioned earlier, we own a subsection, a /16, I believe is what the term is. And we did scan our campus network, and we found several computers, that people had on there. This is something unique about Case. It gave everybody static public IPs.
Make it easier.
Yeah, which made it a lot easier. This is, for us, it was amazing. You don't have to deal with port forwarding and stuff because everything you just plug into the wall and it's public. But it also meant that, for our nefarious purposes, it was significantly more vulnerable. But we did exactly one time. We picked a random IP address and we connected to their Steam account, and we didn't do anything bad on it. We literally just connected and moved around their mouse and stuff, and we got lucky or unlucky or something that the person was definitely at their desktop because they immediately hit Control-Delete, and we're kind of freaking out because their computer was just doing things, and they were trying to close programs and whatnot, and we were just fucking around with our mouse. We didn't do anything bad, but we just gave someone a real good scare.
Yeah, that's nothing. That's just water under the bridge. I presumably you didn't look at any of their personal details, which would have been bad. I think just their Steam account, and they got a little bit of a scare. That's okay.
Yeah, not at all. And we didn't even I don't think we even recorded it or anything.
Oh yeah, of course. I think this whole tale is basically the motto could be, I didn't think I would get this far.
A lot of it. Oh, for sure. Literally everything from day one was literally let's just try it and see what happens. And every day we would encounter something new that would be as we talked about, it would be a new piece of the puzzle or a new clue to our investigation, to the point where we were holy shit, it works. We literally said that a lot of times. Yeah, it's been quite a journey.
All right. Thank you so much for your time, Diego. I must say this was probably the most fascinating conversation so far. Like this was amazing.
Oh, great! That's great to hear. I'm glad you liked me just rambling on.
You,
Hopefully, I don't think my story was very linear, but my memory is fading in my old age. But yeah, I'm glad you enjoyed it. Thank you so much for doing this.
oh, of course, of course.
I enjoyed it a lot, but I love talking about myself. So
No, this is endlessly fascinating. And you're not out of the woods yet. I'll have you back to talk about cars just yet.
oh, good. All right,
Awesome.
do that.
Right.
Sounds good.
Take care, Diego.
You
Bye.
too. Bye.